Everybody, and very welcome to the webinar of today. You hear me speaking. My name is Christian van Klappek, and I will be hosting this webinar together with my colleagues today. Maybe before we start, I see some people connecting right now, so I hope everybody will join us now in a few minutes. But maybe as a starter, to show you some housekeeping rules or suggestions. So as you may have noticed, you are muted when you join the meeting. Although we would like to have a very interactive session where possible. So please do use the Q&A if you'd like to ask a question or have a comment or just want to interact in some way. Please do so. We will foresee some time also later on in the session just to answer your questions. So please do. We've prepared just a question for you also, so you can share your thoughts, and we can make it as interactive as possible, based also on your ideas about AI. So there will be a question along the way in a few minutes. After this webinar, we have prepared a survey for you. We will be very happy if you would take the time to fill it in. It will be a short survey, just a few questions, just to hear what are your thoughts about the webinar, what did you miss, what are your suggestions. So we're looking very much forward to hearing your experience, of course. So thank you in advance. After a few slides of introduction, you will be asked to log on to a tool called WooClap. In WooClap, you can answer a question. So you can already take the time right now just to scan the QR code or to go to the link presented on your screen. And in a few minutes, there will be a question popping up on your screen, which you can answer directly via your mobile phone or your laptop or tablet or any kind you like. So I will repeat this, but if you are connecting right now, that's possible. So today, besides myself, we prepared this webinar with our team, of course, and involved in our team are, of course, Christian Pauwels, who is our general manager. He could not be here today, unfortunately, because of a holiday. So that's not that unfortunate for him. But my name is Christian van Klappek. I work within the CPM team in the Benelux region. I will be sharing some information about AI in the coming minutes. And then my colleagues Koen and Stijn are also involved, and Koen will take over with the demonstration part of today. Koen, maybe you can also introduce yourself short.
Thank you, Christian. So my name is Koen de Kokke, and I work at IBM in the Business Analytics department, where my specialty lies into the data science solutions, of which the predictive forecasting we are showing you today is certainly a part of. Thank you.
And also my colleague Stijn is joining us today. Stijn, maybe a short word.
Hello, good afternoon. Also, very welcome from my side. My name is Stijn Hermans. I am the new business development responsible for Aexis Belgium within the CPM department. Today, I will not be presenting, but if there's any questions after the session about planning, budgeting, forecasting, or how to integrate IBM Watson within our solutions, feel free to reach out, and please do enjoy your lunch.
Also important, good to mention that, Stijn, thank you. So the agenda for today, after a short introduction, we will talk about, of course, the topic, which is artificial intelligence and machine learning. We will talk a little bit about what it is, and of course, what are the benefits we can realize within finance. And Koen will actually show how it's done using IBM technology. After that, we will have some time for Q&A, and we will wrap up. So we approximately will take until 1:30 based on the agenda, and then so everybody can enjoy the afternoon afterwards. A short introduction. Some of you may know, I think you know IBM, at least by name. Some of you also may know Aexis. Some of you may don't know Aexis. Well, actually, Aexis is a company active in the domain of corporate performance management, business intelligence, and analytics. And ever since the foundation of our company, it has been our goal to help our customers with steering their businesses with the best information possible, so they can really benefit from their data and take advantage of technology that's out there. And it's our job, our role to help them with it. We are working from our offices, which are in Belgium, the Netherlands, France. We work in Luxembourg. And of course, from our offices, we have a team of consultants largely who have experience with data, with finance, with technology, with processes, so they can help our customers achieve their goals. We work with lots of beautiful companies around Western Europe and even around the world. These are mid-sized and enterprise-like organizations in many sectors. So we are typically involved in a lot of branches, like for instance, the telcos. We work within food and beverages. We work within multimedia. We work within pharmaceuticals, insurance companies, banking companies. So we offer service to a very large set of customers. Of course, a shared common topic within these companies is that we offer them services related to information processes, related to finance, related to CPM, related to BI, to analytics. And besides these companies, we also offer our own software solutions for vertical markets. So, for instance, to local governances and in the healthcare markets, which we are active. Well, if we look into these services we have within, like I said, corporate performance management, business intelligence, and data management, we will act as a one-stop shop for our customers. So we want to provide everything from Aexis to our customers. That also includes implementation, technology, software licenses, advisory, assessments, workshops, project management. So we offer a full stack of technology and supportive services to help you realize your goals. And within those services, of course, we depend on our partnerships. We work with a lot of great vendors to realize these goals. And one of our main strategic partners, who has been our main strategic partner for many years and will be for many years to come, of course, is IBM. And IBM offers a lot of innovative, great solid technology in the field of business intelligence, CPM. So think about domains in planning, budgeting, forecasting, dashboarding, reporting, analytics. But IBM is, of course, also a leader in the field of artificial intelligence. When it comes to the topics of today, when we look into the field of data science, the applications of machine learning, IBM has been out there for a large amount of time and will be out there, of course, and has a lot of experience and a lot of great technology to share with the world. So that's what we like to introduce you today, of course. If we then move on to the topic a little bit, and before we really pop into the technological part of the topics, I would like to start from basically the domain of finance, because that is really a main competence within Aexis and within IBM technology, within the analytics portfolio. And also a lot of you are joining us today are active within finance or related to the finance department. So that's a good starting point, I think, when you look at technology, to start from really the processes that we should support with the technology. And if you look at finance, well, of course, there are a lot of processes which are included within the finance department. So first, you see 4 dots on the screen, and of course, there is the accounting part, there is the treasury part. So of course, it's needed to keep the books up to date from a treasury perspective, to manage the accounts receivables, accounts payables, making sure the invoices are paid. The cash flow is as expected. The cash flow is optimal, of course. It's optimized where possible. But on the other hand, there's also, of course, within finance, the reporting aspect, and that includes also proving the insight needed to steer the company. So in some larger environments, for instance, this may include having data from multiple systems, which you can maybe need to map to a central structure. There might be multiple charts of accounts. There might be multiple currencies involved. There might be some challenges with managing intercompany balances, creating consolidated reports, working with all kinds of calculations, maybe from a managerial perspective, translating the data to present the KPIs for the management, to present it in dashboards, to follow up on actually how the actuals compare to the budget. And that involves a lot of very highly intensive, knowledgeable work, of course. That of course includes systems, it includes data, it includes technology. And that's also why the 4th element on this slide is presented. It's called the finance IT expert. Maybe not the first thing that comes in mind when you look at finance, but of course, especially today, there's a lot of involvement from IT within finance. So basically, everybody in finance, of course, knows Excel, works with Excel. But there's also the reason why we need BI tools, why we need planning tools, why we need forecasting tools, because in the end, a lot of people within finance are really Excel gurus within the company and are really working with a lot of data, a lot of systems, and are really capable of having a lot of technical capabilities in the end to perform all these advanced jobs. So that's also the reason why technology should support finance. And that's the reason why, like I said, Excel and BI tools are out there. And that's also where a technology like AI can come into place, we think. So if you look into this technological set, we come up to the first question, basically. If you look into the domain of finance, if you look into the way actually finance works, in your opinion, if you look into these job roles within finance, in what parts could AI have a benefit, or more specifically, what in your situation, in your experience, would be for you the main benefit AI could bring you if you look into the field of finance, and specifically to financial forecasting, the topic of today? How do you think AI could bring a benefit? Well, if you visit the link or the QR code on the screen, which I've presented earlier, which is on the screen right now, there should be an application popping up in which you can answer your questions. So I'm going to give a few minutes time to answer the question, then we can look at the results. So things coming in, popping up right here. So people are entering some input. So I see some things coming up: cash, sales margin, reliance, bookkeeping, cash, extrapolation, of course, input, automation, scenario analysis, yes, trends. Yeah, forecasting. Data driven, that's a good one. Yeah. But as you see, there's a lot of things that involve input of data, working with data, extrapolating data, calculating, forecasting, scenarios, trends, and of course also some answers really to the topic, which are also good when it comes to where you can have an application on AI, like for instance, sales margins, that's a good one. Pre-population for a forecast, for instance, pre-population used as a reference. Causality, yes, causality, that's something that AI can definitely help in. So thank you. So this gives us lots of insights and a good idea of what people have in mind when you think of AI, which is such a broad topic, of course. A lot of things that we see within this words have to do with one thing, and that's in the end it's data. And that's also what you, if I could switch for a moment, what you see, of course, within many organizations is, yeah, it involves data and doing something with the data for a purpose, like the forecast, like cash, like margin, that has to do with it. But it starts with data, and that's also when we come back to, okay, why we need AI and what could we realize with AI. That's basically the topic of the day, of course. What you see within lots of organizations is that data is key. We know data is important, but what you see is many organizations have problems, or they struggle with structuring the data and finding enough data, finding the right data, or really having a process in place to do something smart with the data. And that's basically also summarized in a phrase that I came across a week ago, and that's called basically we are data rich but information poor, or sometimes just referred to as DRIP in abbreviation. I found it a fascinating sentence, and it's kind of old. I found out. I did some research and I found out that it's already mentioned in a business book in 1983. So that's almost 40 years ago. And then the problem was still the same. There was enough data. There was basically maybe too much data even already, but to process, because the data was not the problem. The problem was we lacked the process of doing something smart, something beneficial with the data. And actually, that's in a large part, of course, it's different over the time. There have been many evaluations, many evolvements over data and technology and businesses, what we can do. But in the end, it's still the same problem. It's more the problem of lacking the process than lacking the data. And that's, I think, where technology can come into place. If you then take it one step further and you look at technology like AI, machine learning, there's of course a lot of buzz going on around these terms, around these phrases, these technologies. And if you look into what it really is, and what really is AI, what is machine learning, there are a lot of definitions out there. I speak also with a lot of organizations, a lot of customers on a daily basis, and I hear some confusion about it, what it should be, what it brings, what it is from a software perspective. So it's not that clear. There are multiple definitions, of course. Definitions shown on the screen right here is brought to you by IBM. And there's a few things that I would like to highlight in this definition. And that's from a term of software, from a software perspective. It's a form of intelligence that is non-human, as you can see. It's human-like intelligence by a computer. It has to do a lot of things, and some things that are highlighted like that here are important. So it needs to be able to learn, it needs to be able to understand, it needs to be able to do something smart with it, which is human-alike, like making decisions, responding, solving problems. We have to do something with it which is smart and it's not really programmed up front. So, and there are of course a lot of categorizations and a lot of sub-definitions, like for instance, the kind of smart AI you have out there, from very limited artificial intelligence, like for instance, just reactive machines. And one example is of course from a lot of machines that are out there that are actually just programmed to do something and you can interact with it, software or that robot or whatever, and then it reacts on a programmed way. Like for instance, a classical example is the chess robot brought to IBM before. It's called Big Blue. It was really just programmed by the rules of chess, and it knows based on the actions of the opponent what to do. And it, of course, it can calculate scenarios very fast, and that's why it's quite successful. But it's not really a smart AI. It's just a programmed robot that does what it's programmed to do. The more advanced AIs are more about doing something smart and learning and understanding. And of course, on the other end, the other side of the spectrum of AI, there are fully optimized robots that are even able to recognize thoughts, emotions, are self-aware. And that's the other side of the spectrum, which is more of a science fiction movie situation today. But that's of course, the most advanced way of AI when we move forward. There are a lot of applications of AI, and that's also where machine learning comes into place, which is something we're gonna talk about later on also, and which is Koen is going to show you in the demo as well. And machine learning is actually an application of AI. So machine learning is a technology, and the basis of this technology is that a machine or a software learns from what happens without that it's specifically programmed to do so. So it learns based on the experience that it has. And that's basically the main application, and that's what we see in a lot of technologies and a lot of softwares today out there. And that's also the application of AI that most scientists agree upon, that is the way to move forward. This is something the world has to investigate further in order to move forward with AI. Now, if we look into the topic AI and machine learning, there are a lot of applications out there. So we all have things in mind like automatically driving cars and robots that understand language and chatbots and all kinds of things that we see in the news actually every day, like automated receptionists at hotel lobbies, of course, smart devices in your car or in public transportation we see every day. So there are a lot of applications out there, but what is actually the application for finance? And then we have to look into processes like we talked about financial forecasting. We have some input from you from financial forecasting, and that's where the applications came into place. And another phrase that I read the other day is actually also nice when somebody said Excel saved us from manual accounting, and now AI is here to save us from Excel. If that's totally the case, I don't know, maybe you agree, maybe you don't, but AI should be beneficial for people that work in finance to save time, to do things smarter, and to benefit from the data that you have right now, of course. So if we look at the applications, there are a lot of examples. So here's an overview of what IBM offers. Within IBM, it's Watson Analytics platform. So this is a platform for business users and data scientists in which you can actually just build all kinds of applications based on also on templates. There are also a lot of predefined formats, predefined applications. And we're going to look into the forecasting part today, later on in this session. And the application of forecasting, of the application of AI within forecasting should also, of course, allow to have us to share with us some benefits. So it should be, when you look at processes within finance, that it eliminates jobs. So for instance, in the past, of course, a lot of highly repetitive jobs have been also automated by software yet. And they are being automated by robots today, of course. But maybe AI could move into a little bit more intelligent technology that helps us to do a human-alike tasks more. So a clear example that's available is, of course, forecasting, something a computer can do very well. A software could do this quite accurate, quite consistent, timeliness, or very much frequent. And when you have a good set of data available with a lot of data, a lot of parameters, and you could do a root cause analysis on it, and you can find really what interacts with what are drivers for outcomes. Then you could have a computer calculate the outcomes of your forecast basically anytime you would like, as much times as you like, for many scenarios as you would like. And that's where AI comes into place, of course, when it could be beneficial. Does it replace the human factor in forecasting? No, I hardly think so. But it should enable us, of course, to have a better insight into the future based on the data that we have today. And there's a quite interesting model out there, which we can use just to share with you the idea that we have on how to move forward, and what Koen is going to show in the demonstration. And that's a model that's presented originally by Paul Schoenmaker. It's called the uncertainty cone, and I'm going to present it to you just to share with you the idea. So here you see a timeline. On the left side, the present. On the right side, we move into the future. And the idea is that we have some multiple scenarios here, and the farther we are away from the present, the more we evolve over time, the more possible outcomes are out there, and the wider, of course, the outcomes could be, and the wider they are away from each other. So that's called the uncertainty cone. And the idea is that if you draw a line around these scenarios, that you see that in the present they are close to each other, and the farther we go away in the future, it becomes a cone. They are more away or even. This is a simplified view, of course. There are 4 scenarios. There are endless scenarios. As farther as you move away, the more endless the scenarios will be. In a simplified way, there are only 4, just for an idea. And if you look into this graphical, then you could see there's, on the short term, there's a kind of time which we call a predictability span, which we can say something about how predictable it would be, the outcome. Of course, depending on what is a short term for you, that depends on your business, that depends on the situation that is, of course, going on. If it's weeks, if it's months, if it's only days, maybe, that's, of course, very much depending on your business. And maybe today, with COVID going on, for instance, it's sometimes even hard to say that it is predictable anyway, but there is, in a shorter term, a more predictable span of time than in the long run. And that allows us to think about, okay, in the traditional ways of forecasting, of learning from the business data we have, of learning from the information we have as humans and the information that we know from the past, that allows us to have a view on the short term within forecasting. When you look into the longer term, it's hardly the case that the information we have and we can interpret as humans says anything about the future actually. So that makes it's harder. And that's basically where a technology can come into play. So technology like machine learning could, of course, not predict the future. That's not possible, but it could provide us with having a more better or clearer idea about what the future could be, taking into account all the parameters, all the scenarios, all the data, and can help us calculate it automatically for a large number of scenarios at any time we would like and update it as much as we like. That's where a technology like machine learning can come into play to help us really to look into the future. Then if we move further to the technological part, we're going to look at the IBM technology. IBM is, of course, like I said, a leader in machine learning in the field of the AI actually. And it has evolved some, besides only technology, also a lot of methodologies and advisories about AI based on numerous hours and projects of experience with AI. And that's when IBM came up with something called the AI ladder. And that means that you start with, there are 4 main steps within an AI project. On the lower side, there's collection and organize, and those are very critical steps to take into account when you start with any AI initiative. Because a lot of projects, or actually most of the projects within AI that fail, they fail not because of the AI application of the technology implemented, they fail because of the data which is used for the AI application. So the first steps are to collect and organize the data so we can start with our application, with the thing we actually want to achieve. And then we start with analysis and infuse, which means that we can work on an AI application, experience, just try things out, just play, see what works, what doesn't work. And then you can further consolidate the results, and then you can infuse it within the entire organization, operationalize it, and then you can move further with your AI application. So that's not one big mountain to climb. There are multiple steps to take, and then you reach the end result. That's the idea. If we look into this AI ladder, there are a lot of tools available from IBM that can help you with setting your steps in AI, no matter where at this ladder you would like to start or where you're at right now, what the current level of AI operationalization might be in your organization. But it's something Koen is going to tell you about. In a short demonstration, he will show you in quite a fascinating way how IBM technology can help you. And we're going to move over to Koen for a moment because he has, I think he has set up his demonstration already, so we can shift to that. I give the word to you, Koen.
Thank you, Christian. So what I'm going to present to you in a short demonstration is how we can use artificial intelligence or machine learning, in this case I would say machine learning, we are an e-business retailer, and in fact we have 3 product lines. We have men's clothing, we have women's clothing, and we have jewelry. And we have some quantities we have sold, we have some values so it came in, and of course there is some seasonality in the data. Now, what we want to do is we want to forecast the revenue for the next year for each product line, and in fact we will be using 2 different approaches. One without predictor variables and one with predictor variables. So let me show you how this works. So I'll start to share my screen. So here we are in IBM SPSS modeler. This is available in different flavors. This is just one of the flavors, which is a desktop version. Now, first thing we need if you want to build a prediction is get some data in there. As you can see here, if I go to sources, there are a lot of different data sources available. Mostly in a real life situation, you would use a database. In this case, I'm just using a statistics file. If I open this up, and I choose my file, which is this forecasting base file. Now let's have a look at the data set, what's in there, and let's do a preview. So if we look at the data, maybe enlarge this a bit. Yeah. So if we look at the data which is coming in, we see that we have a date, of course. These are only in a preview only of the first 10 records. So we have data from January of 2011. So we have 10 years of history. And we have some, these are the units sold for men, women, and jewel products. And we also have the value. We also see that some other variables, and then we have some variables which are variables which describe marketing campaigns which were run in that specific period. Now, why are we using value instead of the units sold? Well, the fact is that you can have a seasonality, of course, in your sales, but also in your value, because especially in an e-business or in a retail business, it's quite clear that you have certain sales periods. Like in this case, it's January and February, and then July and August, if I'm not mistaken. You have certain reductions on your product, so this will influence your value. So you cannot just multiply the number of units with a certain value and then get a good result. So we have to predict the value and not the units sold. This being said, now what can I do in this data set? You see that you have several different things we can do here already. Now I want to filter the data because some of the things I don't want. So what I do is I want the date, and I want the values I want to predict, which is the value for menswear, the value for women's wear, and the value for jewelry. And all the other variables are not taken into account now. There's also a type note, and what does the type note do? It tells me how I should treat what I should do with the variables, with the values. Okay, I want to read the values. What I should do with these variables in the upcoming steps in the stream. My date is an input, but my men's value, my women's value, and my jewel value are the things I want to forecast in a predictive way. Okay. Now this is all set, and now I can go into my modeling. As you can see, this is a complete data science environment. So it has a lot of modeling things we can use. In this case, we're interested in time series. Now, if I open this up, I don't have to look at this. In my data specifications, I just say that the date is my date field and my time intervals are months. And in my model options, I can say that I want to predict the next year. So I want 12 months into the future. That's basically it. If I run this, it will build the models. So now at this time, it's building 3 different models for menswear, women's wear, and jewelry. So it's running and it's complete. So it's done. Now I could look into this. Might be a good idea, but let's not do this now. Let's just say, what has it done? And if I take a table, which is just a view on the data, preview just takes the first 10 lines. The table takes the view on the complete data set. If I run this, and now you can see that it has created a few new variables. There's this future flag. Let me put this a bit bigger again. Yep. There's a future flag, which is 0 when we're in the, let's say, the period we are using to build the models. And it's a 1 in the period we want to predict. Of course, we don't have any actual values here because they don't exist. But what we have is a lot of, let's say, predicted values. So we have the value for men's, the value for women, and the value for jewels. Now, there are also some other things which have been calculated. These TSLCI men value. What does this mean? If it creates a model, it also creates boundaries around that model. And these boundaries consist of a lower confidence interval, which is this one, the lower confidence interval, and an upper confidence interval. So if your values, your observed values, are within that range, these boundaries, you can say that the model captures the observations well. Now, of course, if we are, I will close this. If we are, we want to write the data back to our systems where we can use it in our planning and our forecasting tools. What we want to do is we just want to have the future data. How do I do this? I just put in a select. where I say that I want to include only the records where the future flag is 1. What we saw is if it's a future record, the future flag gets a value of 1. So I just want to select those. Okay. And the next thing I want to do is I don't want all these fields in the data I want to write back. I just want to have the date, the men's value, the women's value, and the jewel value. That's all I want to write back. Maybe you also want to write back these upper and these lower confidence intervals, up to you. But for this case, I'm not going to do it. And if I look at what is going to be written back, I run this table and you can see that it's, oh, sorry. Maybe the date is also interesting to keep. So you can see if you do something wrong, you can just go back, change it, and then it's okay. So what we see here is for those dates, now at 2021, and for 1 year up to December, from January to December, you get the values, the predicted values for menswear, women's wear, and jewel wear, and jewel values. Okay. So this is basically how you build a model. Now, maybe you're asking yourself, yeah, that's so good and well, but how do I know if this model is any good? Well, the easiest thing to evaluate that is let's use a graph. And this is a time plot graph where I can say I want the dates on the x-axis, and I want to have a model and a view on my 3D time series. So okay, and I run this. And now what you see is that, okay, the dots are the observed values, so the real values. The line is the model, what it says, what it expects to be the values. And you can see that at a certain moment, okay, we don't have any observed values anymore because we're in 2021. You see that it predicts into the future with a certain upper and lower limit. Now, what you also see is that some of the values are not captured. They are close enough, and you could say, okay, in this case, I'm saying I don't mind that it has that doesn't capture some values, but it's quite okay. It's not substantial, so I'm happy with this, and I put this into production. In fact, what we have done now is what you get in if you're using IBM planning analytics. This from the end of last year, I think it was released at the end of last year. You have predictive forecasting in there, and this is exactly what it does. And most of the times, okay, you can say this is a quick and dirty approach. Most of the times when you're in budgeting phase, this is what you do. Is that a bad idea? No, it's not. It is not. And if you're in budgeting phase, you may have one big constraint, and it's time. So this goes fast, it goes good. And normally we're talking here about 3 products. You probably have tens of thousands or hundreds of thousands of records. And maybe this just straightforward method works for you. That's good. But we can go further and we can have a little look under the hood. That's the first thing I want to do, because you can say, okay, is this model really the best model for my data? How do I know that? Well, let me show you what happens behind the scenes. Over here, we also have some build options. And the build option, which is standard, is expert modeler. What does this mean? That it will check for every model it has available. And let me show you, if you look at exponential smoothing, it tests like these 13 different models. And it also tests the ARIMA models, an ARIMA model. And then it will look at which model suits best or fits your data the best, and it will apply that model to your data. Now you can say, okay, but maybe it does that for one, but does this model fit all of my data series? Like here I have 3 different data series. Does this model fit all of my data series? Well, no, it doesn't. So what does it do? It does this exercise for every one of your time series. So if you look at, and this is really for the statisticians in a way, let me put this also on the screen. If I look at the time series for men's, you can say that you see that it's using Winters additive as a model. If I look at women's, it also uses Winters additive. But if I look at jewelry, you can see that it uses Winters multiplicative. So it doesn't say, okay, this model is a one model fits all. No, it will look at every individual time series, every individual trend, and it will choose the best model for that specific series of data. So that's great. Let me close this. Smaller. Okay. So if you're happy with this, just use this. Now, what we saw is that in the data set, if we go back to the data set, if we go to the filter node, we saw that we also had some marketing data, some marketing contacts here, some marketing promotions. So in fact, it's just information about the marketing campaigns which are running at that moment. Now, in this case, we just have 4 or 5 different variables for that for those marketing campaigns. Now, in real life, if you're in a banking context, you might have hundreds of variables which might be used as predictors. In this case, we just have these marketing parameters, and we will see whether these have an influence on our modeling, yes or no, if we use this. Now, just going back to my modeling node, to expert model, we saw that here it also has ARIMA models. Now, ARIMA models, they are extremely well in using predictors. The other models not so. So, in fact, what we want to do, we just want to rerun this and see. Just a second, I have to change something here also. If I look at my type node, I will say that these marketing values can also be used now as an input. So use these to try and predict whether, to try and improve my prediction or my forecast for the next year. So all I have to do is run this. So I haven't changed anything in the data in this modeling node, and it creates 3 new models. And what we see here, if you look into the models, is that now it is no longer using for men's value, whatever. It's no longer using these exponential smoothing techniques, but ARIMA models come up. And what you see is that it also gives the number of predictors it's using. In this case, in the menswear, it's using 2 predictors, and these predictors are the marketing contacts and the marketing follow-up campaigns. For women's value, if we go to the model information, it also uses an ARIMA model now, and it uses 3 predictors, which are the marketing contacts, the marketing spend, and the marketing service level. And for jewel, I think it's the same thing. Yes, marketing contacts, the spend, and the service level. So that's okay. So now we know that it has built a model with more information. Now, you could ask yourself, yeah, okay, it's built another model and it's using ARIMA and it's using predictors, but is that model really better than the one I had? Well, the fact that it's the intelligence behind the software, or the real artificial intelligence behind the thing is that if it selects a model using predictors, it checks if it is better than all the other models. And if it's better, it will choose it. So you don't have to worry about it. If it chooses the model, it's better than the other ones. If those predictor variables I introduced were totally random and had no influence at all on my sales values, it would still use exponential smoothing models and it would ignore the ARIMA models. Now, if you look at the graph again, so I didn't change anything. What we see now is that look, here you had an outlier in the first thing, and now it captures it. So it's even here I can see that it's a better model. Now, what do? I do exactly the same. I write this back, and in fact, I have the same output, only these are better predictions. Now, I can understand it to say, okay, this is a more complex system, and that's true. Will I be able to do this during my budgeting round or my budgeting phase? Maybe not. During your budgeting phase, you may want to use just the simple forecasting I did before. And if during the year you see that your forecasts are not what you would like to have, and that your actuals are a lot different than the things that were forecasted, well, the first thing you do is you go to your analyst and you blame him, after which the analyst will blame the software. And then, of course, maybe you're back to square one and you're using manual forecasting again. A better idea is to see when you're in a phase, when you're not in a budgeting phase, to take some historical data and build things like this, and really have an analyst go deeper into the modeling. Because now I'm just using 4 external predictors. Well, you could try and test hundreds of them. What you also could do is have a look at, okay, we have these men's values, okay, but you also have the units sold. Maybe these units sold from, let's say, women's wear also have an influence on the sales of my jewelry. Maybe I can introduce that. Those are all things you cannot do in a budgeting phase. I understand that, but from a data, if you have the time and you have an analyst who has some time at hand, let him have a look at it, see if he can build better forecasts, especially for certain products or product lines or services you're offering, which are really critical, where of which the values are really critical for a business. I would suggest that you really get someone to look at it and do a finer forecasting. And in fact, this is what I wanted to show you. So let's go back to the presentation. I'll stop this. Okay, so if we go to the next slide, maybe. Now, what you saw here was in fact SPSS Modeler Professional, but the same thing, more or less exactly the same thing. The user interface may look a little bit different, but you can have this in what you saw here, which is complete, easy to use data science solution aimed more or less to business users. Of course, data scientists can use it, but the nature of data scientists is they like to use coding, they like to use notebooks. So they don't like to use with these easy, between brackets, tools. And this is available in a desktop or in a client server mode. You also have Watson Studio Desktop, which has the same capabilities. It's for business users and data scientists who want to do coding. So they can work together on a project where the data scientists are coding in Jupyter notebooks while the business users are using the graphical user interface. Also available in desktop and in client servers. You can also have Watson Studio as part of Cloud Pak for Data. Now, Cloud Pak for Data is IBM's analytical platform, which encompasses all the items Christian was talking about, like collecting your data, making sure that all your data is available, having search functions on your data to find which data you can use. It has organizational features like governance and security on there. It has all the analytical capabilities, of which this is only a very small part, because you also have BI in there and so on, and decision optimization and other things, and everything you can want as a as a data scientist or as in your analytical environment. And also it helps you to infuse, which is in fact deploy your models towards within the organization and even to your customers outside of the organization. So this is what I wanted to talk to you about, and I'm very much open for questions now. Thank you.
Yes, Koen. We received two questions in the Q&A section. The first of all is how much base historical data is required for your setup or for your predictions?
Well, that's a very good question, of course. That's the American way. We always say that they always say that every question is a good question, especially if they don't know the answer. But in this case, I know the answer. Now, in fact, use what you have. If you only have 1 year and you want to predict the next one, do it. If you have more than 1 year and use more, and use what you have. Maybe it's not very useful to use 10 years like I did here. Sometimes it may be, sometimes it's not. But as soon as you have data, use it, I would say.
Okay, thank you.
You don't need to have, I say, let's say 5 years or 3 years or 2 years. Work what you have. If you have more data, of course, your models will improve. That's clear.
Great, thanks. And another question came up at the beginning of your session. It is about what is your confidence interval? He's talking about 95%. So what is this confidence?
Well, then the confidence interval is 95%. What does that mean? That the model estimates that 95% or at least 95% of your observations should fall within that confidence interval. So observations which fall outside of that confidence interval, that's what we call outliers. And in some cases, if these outliers are quite frequent, what you maybe want to do is, and which is a good idea, of course, you may not be able to do that under the time constraints of a budgeting phase, but if you're doing deeper analysis of your time series, you can collect these, or you can easily select these outliers and send them to your sales managers or your product managers and ask them, okay, what's happening here? Why is there an outlier here? And based on the information coming back from them, you can even, but that goes too deep into the software for what I wanted to show today. You can even have the model detect those outliers and handle them in a specific way based on the reason why these outliers occurred. Because a reason can be that you launched a new product line. If you launch a new line of, let's say, menswear, this will have a peak which may lie outside of your confidence interval, but it will also have an effect on the next months or the next years even. You can also have a one-off sale. It can mean you have a large order came in and you will have this for one time, it's a one-off. It will cause a peak. Then in this case, you will tell the system, okay, if you enter a peak like that, just ignore it because it's a one-off and it will not influence anything into the future. So that's what this confidence interval is about. It's looking at, okay, these are the boundaries. The line is, okay, this is what the model predicts. The boundaries, like the confidence interval is, okay, if the observations lie within that area, they are, I consider them as being within the boundaries of the model. And of course, you can play with it. Standard is at 95%, but you can lower that or rise that.
Okay, great. I think that answers the question very well. If there's no other questions, didn't see anything coming up. There's a big one coming in. Do you have experience with large real estate deal related to transactions pipeline predictability? So I repeat, do you have experience with large real estate deal related to transaction pipeline predictability? For example, how many or which industry related sale, leaseback, large transactions would become available in certain economic scenarios? This is a large question. I'm not sure if you have experience with large real estate deal related transactions.
Well, no, I don't, but I think it's a difficult one to answer in this way, but I think more than one analytical solution will come into play here. Everything can probably be done in the solution I showed you, but there are more things coming into play than just predictive forecasting.
Of course.
Because you want, I mean, even you might want to have some decisioning rules and so in there, because it's a difficult one. It's a nice question. It's a very good question. And this time I don't know the answer. So that was an American. I don't know that's a good question.
No, but that's okay. We will definitely.
But if you can dive deeper into that, maybe guys from Aexis, and we can certainly come back on that.
Yes, we'll definitely have a look at it, because it depends a little bit also on the situation and the data that's coming in. So thanks a lot. We will definitely come back on that one. Is there any other questions at this moment, or otherwise you can of course ask them always afterwards. We will be very happy to reach out to you to discuss the question more in detail. So that's it from the question side. We still have, I think, last slide about call to action, Christian.
Yes, thank you very much. And thank you for your good questions as well, and the answers, and the great demo, Koen. And maybe to comment on one thing also related to the last question. That's an interesting question, and that is there are a lot of possibilities, and that's also where the applications come into place, which we only briefly introduced today, because we dived into the financial forecasting using the Watson Studio, the SPS modeler. But that's also where solutions like the IBM Cloud Pack for Data come into place, in which you have a bundle or a package, of course, of a lot of solutions, and really you have an analytical platform. And then there are lots of ways you can extend it, or you can use it in whatever way you would like it, to solve all these kinds of challenges that involve multiple technologies. So very interesting, and something to further investigate. So thank you very much. And indeed, we almost come to the last of our slides. So if we look into the agenda for 1 second, after the Q&A, we only have a wrap up, and there's basically one thing I would like to mention to you, and that's related to the demonstration and the topics we handled based on the data. Well, if you are curious on how your organization is organized when it comes to data, or how mature actually the organization is in terms of source systems and the capturing and the already transforming maybe of the data to the relevant insights, Aexis has developed an assessment which you can participate in online. It's free. It doesn't take a lot of time, but it shows you just a first insight on how your data or how your organization scores on data maturity. And it also gives you a score for each category, and it includes actually a kind of peer average. So all the other participants also who have shared their insights, so we can provide you an idea of how you score compared to your peers. So it's very interesting. It shows you a first insight, and we can give you some tips and some quick wins based on your input. So quite interesting just to do if you have some spare time, a few minutes. So highly recommendable to do that. But maybe first, if you do have a few minutes, I would like to wrap up. And if you stay in the Zoom meeting for just a second after it ends, then the survey will pop up. So we are very thankful if you take just the time to answer a few questions about what your thoughts are on the webinar for today. Should you have any questions later on, or get into contact about this later on, you are very welcome to do so. Please drop us a message anytime, phone us, visit our website, or drop us an email. You are very welcome to do so. Thank you for being with us for today, and I hope you have a pleasant afternoon.